Hello and welcome. In this presentation, we'll discuss some of the tools that are necessary for capacity sizing. The first area that we have to focus on is forecasting. And forecast is a necessary starting point for any capacity sizing decision. When we think of forecast, we should consider the evolution of several factors. This could include the evolution of demand over time, the evolution of supply, the raw materials and supplier capacity over time, the evolution of technology, which is how the technology is changing the cost of capacity over time, how technology is helping with learning and continuous improvement that can then in turn increase capacity or yield of a company. And finally, new technologies. If there are new technologies that are coming up and they come very frequently, then one has to forecast for those technological changes also. And finally, strategic uncertainty. Capacity decisions should account for competition and environmental changes that are happening as part of strategic uncertainty. Now, forecasting, since it's the starting point for capacity decisions, at minimum, each forecast must specify the expected value, which is the mean demand, and volatility, which is the standard deviation, by the time bucket. Now, standard deviation is one way in which we capture volatility. Other ways that volatility can be captured is by using coefficient of variation, which is the standard deviation divided by mean. Some other examples for forecasting are that we should think of range of values that can happen every time step. Instead of one single value, we forecast a range of values. So it provides sort of a bandwidth within which the future might fall. One can think of scenario analysis. Multiple paths can exist, and one can utilize that scenario analysis to determine what kind of forecasting could happen because of the type of scenarios that can exist, and then potentially take a weighted average of these scenarios. Now, typically the challenges in practice is that most of the companies are using point forecast rather than a range of values. And that can be detrimental, especially when we are thinking about long-term strategic investments in capacity because of the amount of money involved in it. Forecasting requires cross-functional input and agreement, and many times that input has not been incorporated in this forecasting decision. And most important is that forecast often is used to serve other means. It is at times used for goal setting and therefore connected to incentive that is being given to different people within a company. And that can then sort of get disassociated with the actual need of that forecast. The forecast is ideally meant to capture demand, supply, and technological changes. But if it is also aimed at goal setting within a company and therefore setting incentives, then that forecast may not necessarily reflect the reality. And forecasting often serves the means of budgeting and financial reporting. So that's an important part that we have to keep in mind, that whenever forecast is being made for operations point of view, we are looking at it from demand, supply, technology. But at the same time, forecast is also serving the means for budgeting and financial reporting. So that needs to be accounted for as part of the forecasting decision itself. Now, when we are analyzing the financial aspect of capacity strategy, forecast obviously will play an important role because that will determine the size of capacity that we should have. And to value that size of capacity based on a forecast, we need to use techniques that will capture the time value of money, the evolution of capacity decision, as well as the risks involved. So when we are undertaking such a financial analysis, we need to forecast demand, supply, and the net margins that we're expecting every time step. It's important to distinguish between demand from output and sales. Because typically when we are forecasting, we're using past data on sales or outputs and then determining what the forecast should be. But we all know that sales could be influenced by many other decisions company might have taken in the past. It could be advertising, it could be promotional schemes. And if you don't repeat exactly the same sort of activities in the future, then you may not get the same sales values. So when we're taking those sales figures for forecasting demand in the future, we need to understand that difference between sales and demand, and likewise, output can also be influenced by many other factors internal to the company. And if that production output is used as a mechanism for forecasting, once again, there could be discrepancy between the actual forecast that needs to be there versus what was produced in the past. One needs to model capacity adjustments as well as any continuous improvement that could be happening. So when we are thinking of capacity sizing decision, a long-term decision, one needs to account for such adjustments in capacity that can happen, as well as any continuous improvement that can be helping capacity improvements. One should include plans or options for model changes and future new products. Because if you have plans for new products, then you need to have a capacity that can account for those new products as well. The capacity should not be a constraint in developing these new products. And then you have to have a moving baseline. It's typically useful to have a forecast which captures, or the capacity decision that captures two separate discounted cash flow analysis. One is when you do not invest, and the other is when you invest. And then you find the net present value as their difference for these two kinds of scenarios that can exist. And finally, you should capture risk within these capacity decisions. So that's a very important element in long-term strategic capacity planning. Now, when we are taking decisions on capacity, a question that might come up is what should be the optimal capacity? And we know that capacity depends on several things, but there is some bit of formality that we can incorporate in coming up with an optimal capacity. And then that should be a number that forms the basis for then thinking what could be the actual number which we should shoot for the capacity. So here is one way in which optimal capacity can be determined, and this is based on news vendor model that is widely used for inventory related models. Now, if the demand is normally distributed with some mean value of R and standard deviation of sigma, then we can find the optimal capacity for that particular situation with an expression which is K star, which is the optimal capacity, will be equal to R, which is the mean, plus Z star, which is basically a normal distribution, a Z value, based on some optimal service that you want to offer to the customers from that capacity. So we will talk a little bit more later about Z star, multiplied by sigma, which is the standard deviation of demand. So it's a very simple expression. K star is equal to R plus Z star times sigma. Now, Z star is something which we can calculate using some values that we have internally decided for the company. So it will be dependent on the optimal service probability that we want to offer, what that service level that we want to offer. It could be 98% service level that we want to offer to the customers, 95, depending on the industry. You would have different optimal service probability, and also the cost factors will play a role. Now, a way in which we capture this optimal service probability is by taking 1 minus a ratio which in the numerator takes into consideration the marginal capacity investment cost, CK. So what is that cost that we will incur for every marginal increase in capacity investment? And in the denominator, we take the sum of your operating profit margin, M, plus any shortfall penalty cost, C subscript P. So what we are really doing is, what is that ratio of additional cost of capacity investment, marginal cost of capacity investment, as a function, as a ratio of the sum of that operating profit margin and cost of shortfall. And that ratio, when we subtract from 1, gives us what the optimal service probability for the organization should be, because we are accounting for the cost, we are accounting for shortfall penalty, etc., and margins as well. So after a certain level of volatility, it is important to know that the value of capacity is insufficient to cover the investment costs. So volatility plays a very important role in the capacity decision. So if the volatility goes too high, then the value of that capacity would not be enough to cover that investment cost. So one needs to also address the volatility simultaneously to ensure that it doesn't go out of hand. In organizations in practice, capacity or safety capacity, we can call it, which means that you have some extra space available, is one of the decisions that we take for offering products to the market. So capacity is one within which you can have a certain extra buffer capacity. So that's what safety capacity is in this triangle. But you also have some other means for addressing demand. We could have safety inventories. So many times you make products in large quantities, and these products are made at a time when there's no demand, but we are making it so that we have sufficient inventory just in case if demand goes up. So safety inventory. And likewise, safety time, which is very important when many times you don't have the capacity, but customers are willing to wait for the product. In those cases, we can also use that as a lever for managing our demand supply sort of relationship. So most of the time when we are thinking of operation strategy, companies are deciding where their positioning should be in between the safety capacity, safety inventory, and safety time. So they would gravitate towards one of these corners depending on where the marginal costs are lower for the company. Now, the 3 key drivers of capacity sizing are forecasting, the shortage cost, and safety capacity cost. Now, each of them will have their own levels of how you will manage them. So forecasting, you need to take care of average demand. You have to look at that. You have to look at volatility of demand, aggregation, and postponement, because aggregate forecast typically have lower uncertainty than a product or SKU level. SKU stands for stock keeping unit level forecast. So we want to be able to use an aggregate level forecast when we are taking these long-term strategic decisions of capacity so that we can size it appropriately. And then we have to distinguish planning from other uses. So forecasting many times, as we just discussed, that can be used for incentives and goal setting and budgeting, etc. But really for capacity sizing, that forecasting decision that we are interested in is the one which is meant for planning for the demand and supply. So we need to distinguish between the other uses versus the planning use for that forecast. The second is shortage cost, and for that we have again some levers. These are volatility once again, standard loss or penalty shortage that we might have. If we have any shortage, we have to account for that lost sales, and there's a penalty cost for that. Waiting cost for customers, we need to account for those kinds of cost, holding cost. So these are types of cost that will play a role when we are addressing shortage cost as a driver for capacity sizing. So if we are having more inventories in stock, we are holding them, and therefore there will be cost involved. If we are asking customers to wait, there's a cost for customers to wait, and we have to take into consideration that part. Shortage again has a penalty involved, and that is something which we need to account for formally when we are addressing capacity sizing decisions. And finally, for safety capacity cost, which is one of the drivers here, we have to account for discount horizon and discount rate. Like how long are we thinking about, and what is the rate, which is typically the cost of capital that needs to be accounted for the safety capacity cost. And we have to understand the marginal cost of capacity versus inventory, capacity versus subcontracting it, or providing overtime, temporary workers being involved in it, or even spot market buying. So investment in capacity versus these other options that can exist. We need to take into consideration a marginal cost between those two options, or between these options. Now, some of the tools to incorporate risk into analysis, because risk, as we just discussed, is very important aspect of capacity sizing decision. We need to have some tools that can help us address that risk factor. Number one, we can use scenario analysis, which could be concurrent scenario analysis, or it could be discrete level scenario analysis. We'll see some examples down below here, where one of the ways in which we do scenario analysis is to determine the factors you will be building around. So what are the different factors that can play a role in creating these scenarios for capacity decisions? And then using those factors as a basis. This could be macroeconomic factors. It could be internal factors that you have for some strategic planning. All these factors will then tell you what the scenarios should be. What are the kinds of scenarios you could expect in the future? And then you have to assign some probability to each of these scenarios. And you estimate cash flow for each of these scenarios, and then compute expected net present value for these scenarios. So that's the typical sort of steps that you take for scenario analysis. Decision trees can be, again, a useful tool for scenario analysis. Scenario analysis is more of a static decision tree, whereas decision trees are more dynamic, where you have sequential, discrete decisions happening at different times. So we will talk a little bit more of these timing decisions later, but they are useful for incorporating risk into capacity decisions. And then simulations are obviously allowing you to take multiple scenarios in consideration, multiple timings in consideration, and that also helps in incorporating risk and understanding a little better what the capacity decision should be. Now, to be able to address risk, we also need to know what is risk in capacity decision. It's defined as the likelihood of something happening multiplied by the impact or consequence of that particular event. Right? So these are undesirable consequences of uncertainty that can exist, which we should consider as part of the risk. We have to think about variances involved in our forecast. We have to think of it in terms of variances with regards to how we are offering the product to the market versus what this risk factor can do to that variance itself. There are two types of risks. One are the operational risk, which is what we are discussing, and the other are the financial risk. Now, operational risk revolves around real assets. Right? These are assets like capacity assets, fixed assets companies are investing in, and financial risks are more focused on financial assets. So when we are managing risk in any of these scenarios, whether it's operational or financial, we are controlling the likelihood of something happening and the consequence of that event. Both of them have to be addressed. And we have hedging mechanisms which help in mitigating these risks. So for operational risk, we use operational hedging mechanisms, whereas in the case of financial risk, we use financial hedging mechanisms. Right? So those are some of the things that we'll have to keep in mind when we are deciding on what to do with a certain operational decision like capacity strategy. Thank you.